Hello, my name is Catherine Nguyen. I'm a student at Old Dominion University, and I'm completing a series of demonstration videos for microcontrollers and embedded-based designs as part of my senior project. In this video, I will demonstrate the operation of labs number 1 and 2, LCD module parallel communications with PIC 16F877A. This lab utilizes the built-in LCD connections on the trainer board to interact with the provided LCD module. The objective of this lab is to initialize the LCD and print a meaningful message on one or more lines of the display. Up on the screen I have the basic LCD schematic provided in the lab documentation. The LCD can be controlled with only 4 data lines, but here I am using all 8. You may notice that there are 14 pins on the schematic and only 12 pins on the trainer board. VDD and VSS are already implemented on the trainer board for you via the SV1 socket. As far as hardware is concerned, all that is required is to connect up the data lines, the RS and E lines, the voltage reference, and the read-write line. As always, double-check that your switches, namely S1 and S4, are configured correctly based on the number of pins on the PIC you are using. Reference the appropriate manual for the revision of the trainer board you're using if needed. I'm using the 16F877A with a Rev3 trainer board and have S1 1 to 5 on and 6 to 10 off. For S4 I have 1 on and 2 off. Oscillator connections are required for this lab. The connectors share a terminal with port E for this PIC and are connected directly to the oscillator circuit implemented on the trainer board via SV4. The LCD will need to be inserted into SV1 and connections made from the X29 terminals to PIC I/O. In this case, 8 lines from port B are used to control the LCD. Next we have the register select and enable lines. I have used 2 pins from port C to control these lines. Finally, the voltage reference and read-write lines must be connected. The voltage reference required varies by LCD module, and you will need to verify what's needed for your specific LCD. In my case, the voltage reference and read-write lines are connected to -5 volts and ground respectively. A successful initialization is demonstrated by the printing of a message. In the brief moments after power is applied, initialization is taking place without visible results. For this demonstration I have chosen to use 2 messages, each utilizing 2 lines of the display. The original welcome message remains on the LCD momentarily before being cleared to allow a second message that details the hardware connections to be printed. Finally, verify that hitting the reset button results in proper operation and the same results as when the power was first applied. This concludes the demonstration of labs number 1 and 2. Please see the associated documentation for additional information and further instructions.